So now we're going to be looking at the regularized linear regression. This is also a multiple linear regression model, as we can see that we have several independent variables and one dependent variable. So we again normalize the data so that it's all scaled within the same range. And we also are going to be adding the intercept into the first column, and we're going to be changing the shape of our y value, so our dependent variable, and we're going to be defining our initial parameters. Then after that, we're going to be using the rich regularization for the cost function. As we can see, this one is the one that was provided in the material, but we ended up using this one in order to facilitate the calculation of the partial derivative, which is used in the gradient descent over here. And so yeah, this one over here is the one being used right here. And here we are iterating in order to create the best fitting model, so the best fitting theta parameters as we're moving along the partial derivative of the slope and of the y-intercept. This one right here is pretty much the same one that we used in the simple linear regression. And by doing this, we are telling the model that we do not want to use the first column, which is our intercept column. And here we're doing the same. We're telling it, hey, use every single row, but don't use the intercept. And this right here is going to be updating our theta parameters. And here we finally are training the model with the data that we have and our initial parameters. And we can see here how the cost function is being reduced as the amount of iterations decreases. And then again, the prediction is simply just the matrix multiplication of the independent variables times our coefficients. And here we can see the coefficients that we got for this exact model. And then we are creating a new house, and we are also normalizing it so that it will fit inside our model. And then we simply just add the intercept parameter as 1. And finally, we create a prediction for how our house is going to behave. So if we execute all of these, we can see that the model fits pretty well to the data. So if we come back over here, if we decrease the regularization parameter, then the penalty term will have little effect on how the model behaves. So it's very likely that you will have overfitting. So if we run everything again, we can see that the values are pretty close, and our cost function minimizes very quickly. But if we increase it to, let's say, 100, then we can see that the model no longer fits that well because it's avoiding the overfitting. So the larger the regularization parameter is, the less significance have the data parameters. So like that, the model will avoid overfitting if the model is too complex.